All right, we're going to go ahead and get started. Welcome to North Gravity's webinar, From Chatbot to Crew, Multi-Agent AI for Commodity Desks. From an operational standpoint, chat is disabled. Please submit questions through our Q&A section. Time permitting, we'll answer the questions at the end of the webinar. At North Gravity, our focus is to help commodity and energy teams make sense of fragmented data. We work across pricing, fundamental data, from a lot of different sources, help teams clean, organize, turn it into something teams can actually use for reporting and analytics. We're teams spread across Europe and North America, and we work closely with our clients on real-world trading and risk challenges. Today's session is the third in a series as we try to share our path of expanding AI usage throughout the commodity industry. I'm pleased to introduce Ani Sundaram from the North Gravity team, who is presenting today.
Awesome. Thank you very much, Chris. So as Chris said, my name is Ani Sundaram, and I primarily work with client success at North Gravity. So sort of being the evangelist for our platform and building out solutions for our respective clients. This sort of work has really delved into the AI world very heavily, and we've had experience across a variety of different clients, whether it be refinery data normalization for a big oil company, creating a compliance validation and document auditing system for a renewables exchange, et cetera, et cetera. So we've had a lot of broad experience across the space and being able to deploy automation and even AI solutions at scale. So before anything, I guess let's just kind of walk through what our agenda is going to be today. So as Chris mentioned earlier, this is a third of our series of webinars, so we're going to continue kind of building on the terminology and building on the sort of concepts that we were talking about earlier. We're going to talk about sort of how you can make a system with a multi-agent crew production ready and why commodity desks in particular need these agent crews. We can briefly walk through a couple use cases and then also kind of end things off with risks, controls, mitigation for those risks, and sort of best practices for safe deployment. So to start, let's just kind of go through the building blocks of some of these concepts. So a few of these initial blocks you may have recognized either from your own knowledge or our past webinars, but what is an LLM? An LLM is a large language model, aka a model which understands and then generates language as an output. So consider this your reasoning engine. However, on its own, an LLM itself cannot touch your systems. That's where items like an AI agent comes into play. So think of an AI agent as an instance of an LLM, but with instructions, tools, and memory. So you can set it up to be integrated with certain connectivity, certain connections with systems. You can set it up to have access to certain tools, parse this document, parse that document, et cetera. So it goes past just an answer. It goes into, I guess, approved actions and usage of tools. The third concept is MCP, otherwise known as the Model Context Protocol. So the way we've explained this earlier is sort of consider this the USB-C of connectors between agents/LLMs with the systems where your data actually lives. So this is an open standard set up by Anthropic, which has been broadly applied across the space to allow you to kind of make it easy to where you don't have to make one-off connections with every single system your LLM or your agent touches. You're able to use this open standard. Now, in terms of new terms, let's talk about the term of orchestration. So think of orchestration as sort of the coordination layer. So the layer where if you have multiple agents, you have the ability to tell each agent sort of which agent acts when, how work is handed off, where our audit or our QA-based compliance checks, et cetera. So kind of providing bounds behind the workflows which a set of agents might be working on. And for today's topic, we'll be talking about multi-agent workflows. So think about this as agents with specialized tasks coordinating on one process, including validation gates, including controlled handoffs between them, and including sort of very separate and delineated steps across a process which is being automated. So just to kind of explain this sort of on a visual end, let's just kind of walk through what this might end up looking like. So again, every person has their own sort of chatbot, which goes in, answers questions, and drafts text. This is obviously very helpful, as I'm sure most of the BAs and other analysts on the chat might be aware of. However, it can't alone touch your data or systems. You can kind of escalate upward towards a single agent, which has the ability to be connected to tools, allowing you to conduct approved actions. And generally speaking, a single agent is one worker conducting one or many jobs. So now we get into the concept of an agent crew. So an agent crew, again, as we discussed earlier, splits up this work into specialized agents within that sort of workflow with very clear handoff steps and checks at every step. It's not, I mean, the main point here is that a crew is not merely just a bunch of different agents, a bunch of different chatbots kind of working together. It's a controlled workflow where each agent does one job well. So I guess the question to come up is, why do single agents break down? Specifically in the commodity space, we are dealing with a large variety of disparate sources of data, to say the least, whether it be going through data sources via API, via Exchange, even via, let's just say, broker marks coming in via an Excel sheet. One agent in this sort of world would be juggling every feed, file, and system. And sometimes having all of that sort of context can lead to timing issues and can even lead to accuracy issues. The other main point here is a sort of point of auditability. When you want to ensure your large enterprise trusts the usage of AI, it's important to understand sort of where reasoning may have broken down in select errors. So in the case of a single agent, that one reasoning chain is not separated out. It is just one long reasoning chain. And without those checkpoints, you're in a situation where, one, you kind of are unable to easily determine what portion of your workflow caused a said error. But two, you're also in a situation where one failure can kind of pollute everything and go directly to your respective output. Due to this, again, kind of adding more points to this is you have to be in a situation where maybe that one agent has multiple different tools or approved actions that it can conduct. There is some level of risk with having that one agent have to pick the right tool for every single different situation every single time. So again, blurred responsibilities kind of come into play here where retrieval, QA, analysis, these are not like separate things. These are all in one item. So the real fix here is specialization, having those validation gates, and having controlled handoffs. So now what does a practical agent crew look like? So we're just taking an example here. Let's just say that we're working off of a market analyst desk, and this market analyst has to go in and basically take a bunch of data and synthesize it and create a morning desk note regarding potential trading trends or decisions. In this case, we would suggest, starting with a separated data retrieval agent, which goes in, is able to pull all that pricing data, pull all that fundamental data, and parse it accordingly. We have a validation agent, which before any analysis or before any creation of a deliverable, checks for missing data, stale data, outliers, schematic changes, etc. That goes forward with an analysis agent, which goes in, is able to explain any big market moves, go and see, hey, oil is increased or decreased by a certain amount and figure out what those key drivers are. We can have an agent which takes these respective trends and using natural language, draft the morning note into the desk's voice. And then finally, we can have a review gate where maybe before going to production systems or before being published, this note can end up being reviewed by a human or go through some validation checks. So again, the main point we're trying to make here is it may sound simple, but that validation gate is an incredible key and really is a circuit breaker in this case. Let's just say there's a holiday, or let's just say there's some sort of inaccurate data. That is not flowing through the entire workflow. That stops immediately at that step 2 with the validation before it can pollute down analysis or before it can pollute publishing. The main key here is set up correctly. Every handoff between these respective steps is logged, and every claim in that respective note can be correctly attributed to a respective source or a respective data point, allowing you to kind of do very quick troubleshooting on sort of the reasoning chain, etc. Now, again, this is just another visual to show you that this can be done sort of in a parallel format as well. Again, obviously, IER or refinery outage or fundamental data might be different than how you would parse ICE data or exchange data or NOAA data coming from weather. So we kind of wanted to make the point here that those agents can absolutely work concurrently, however, go through the same validation gate. Again, a specified agent for each of those respective data sources, going through a validation gate to confirm that, the whole no outliers, no schematic changes, and then everything kind of converges towards that workflow we just saw earlier. So analysis, creation of the note, and then human approval. So again, we're just making this point to say that it's entirely possible to be able to do this. Obviously, there are kind of speed implications here as well, as you're able to create specialized agents for each of those specific data sources. Now, with this in mind, why is commodity data a strong fit for multi-agent crews and workflows? Really, it comes down to the truth that I'm sure everyone here knows, which is that commodity data is quite fragmented, quite disparate, and quite complex. The same commodity across exchanges could have 5 different descriptions. It could be varying curve methodologies, varying metadata, like what a certain time zone is or what a certain price is quoted in. And even more importantly, there are varying delivery periods and calendars across instruments. These are all, major complexities, and in a situation where you need time-sensitive decisions, a data problem could very quickly become a P&L problem. All in all, also, we have to also look at the fragmented nature of the sources of these data. Some of these data might come from a Platts or ICE feed. Some of them might end up coming from an API or an Excel sheet full of respective broker marks. Again, you're dealing with a very fragmented and unforgiving situation, and wrong data can easily become wrong trading decisions or wrong risks and operations conclusions. So again, it's important to sort of note that having specialization within each of these sort of components could be very valuable. In what situations would having a multi-agent crew be valuable? I guess a few of the main points here are sort of the parallel data gathering we were talking about earlier. So when you're having to synthesize multiple sources of data, having that sort of concurrent flow that we were discussing earlier can be very valuable. Obviously, having validation with, let's just say, if you're dealing with a little bit more of an unstructured data or inconsistent data stream than usual, it's important to be able to catch bad inputs early and do it by design. Another point, as we were talking about earlier, was regarding on the enterprise side of things. I think that it's very valuable as you develop and refine these agentic solutions to have sound auditability and audit trail. So having every step, every tool call, and every handoff logged really allows you to troubleshoot in case there's some logic needing to be changed within the attached tool for a given agent, or whether you need to explain what is the source of a given output. Having all of this sort of divvied up and having clear separation of duties across every step of this workflow, one allows you to kind of trace back the results a lot easier, and two, it allows for easier human review. Instead of having to kind of continuously monitor this entire workflow, your approval is required in defined gates. So you can, again, understand sort of the previous processes before you receive said output or said data. Now, we just wanted to walk you through a few quick use cases of where a multi-agent crew makes sense. First use case is, again, kind of similar to what we were discussing earlier, the whole automated morning desk note. So again, these situations, from our experience, even with clients in big oil, ends up being quite manual, to say the least. You're dealing with analysts pulling from several systems before writing, and validation of these data sets often ends up being informal and often on an ad hoc basis. And that obviously leads to slowness / inconsistent timing of when that morning desk note might end up even being ready. In terms of the agent crew, as we discussed earlier, we can have a retrieval agent or agents go in, pull the approved data sets for this desk, have a QA agent, again, to kind of check for that stale data, go ahead, identify any sort of main drivers or any relevant analysis, divvy up that morning note, and kind of write it into the voice of the desk. And then sort of a last step where a human goes in, is able to review the sources, review the data, and approve distribution. Again, there's a clear value here in usage because in a situation where there's sort of this level of consistency, this really allows you to have that consistent structure, ensure that no inputs come in without you at least validating and kind of seeing the reasoning chain behind how they're parsed. That obviously leads to having very auditable commentary on a line-by-line basis, and really, all in all, leads to faster and a lot more smoother mornings for these analysts. A second use case, which we've also had experience with, is sort of weather to demand report mapping. So obviously we have weather sources like NOAA, like NWS, like other sort of state-run websites as well. But it's not exactly very clear when you get this weather data what the demand impact is. So sort of in this case, it's important not just to have a forecast, but have comparisons to previous forecasts, have an understanding of how previous forecasts may have affected load or power or gas demand. So, it's not, there are obviously trends which can be very easy to miss in this sort of a situation. So in our recommendation, we would have a separate agent go in, parse the weather data and pull changes within respective forecasts across time, have a demand agent, go to each of those points, go to PJM for load data, go to find data on gas and power demand, and go ahead and also have a history agent, which takes both of these data sets and compares them to past trends or past identifiable sort of similar times. At this point, we can also have an agent, which is sort of a risk agent, which can highlight regions within your data set with any anomalies or abnormal exposure, and then utilize all of this and synthesize all of this data into desk-ready commentary. Again, in this case, we're allowing for much faster interpretation, much faster synthesis of this respective data, and ultimately more actionable alerts. Now, this example is not necessarily an example we've worked directly with the client on, but just a cool example of another place where we have a lot of disparate sources where a multi-agent crew can be necessary. So with respect to freight to arb economics, the whole situation where, hey, you have the same barrel of oil in two different places. Is there a chance where there is a margin present between those two destinations? Obviously, in this case, we have a lot of moving parts along with the respective prices. There's obviously freight and port specifications, quality specs, and all of this data kind of comes in fragmented inputs, whether it be coming in from a spreadsheet or a vendor screen, web scrape, et cetera, et cetera. So again, similar sort of concept, once again, where we're going in, we would recommend having an agent to kind of go through those port and freight and vessel specifications and assumptions, have a market agent to pull the origin and destination prices, understand your constraints that you're working with whatever product is being shipped, have an agent which goes ahead, calculates those landed economics, and then have a reviewer go in to kind of figure out, hey, what potential trading decisions can come after this, what assumptions were used in this sort of analysis, et cetera, et cetera. So again, obviously, we would recommend some human approval here before any sort of trading decision, but we're, again, doing the synthesis of data. We are going through and separately parsing each of those disparate sources to kind of come up with a bigger picture of what are our constraints and what are the ways that we can actually make an arbitrage off of this respective barrel of oil. So we've gone through 3 different examples, and they're in 3 different, I guess, 3 different disciplines. However, they really all kind of follow the same approach. So each of them has sort of a segmented and separated agent crew, separated off by function or by thing that is being analyzed. We have very similar inputs, whether it be prices and curves on one side, weather data on another side, or even port specifications on another side. All 3 of these steps also have validation gates, so confirming you don't have stale data, doing a sanity check of a weather forecast compared to history, or doing a review of assumptions made when looking at constraints of landed economics for a barrel of oil. And in all these respective cases, you're kind of in a situation where you have that final output. The point I'm trying to make here is these are completely different kind of use cases, but all kind of follow the same flow, and it kind of doubles up the point that if you can describe the workflow and you can describe the sort of checks you need for it, you can certainly build a crew for it. Now, we don't want to be completely rosy or optimistic without reason, and it's also important to understand when a crew is not necessarily needed. So some of these answers are obvious, right? So like some of them include the like sort of one-step flows where maybe I don't really care about the market implications behind a specific piece of data. Maybe I just want to parse it. Maybe there is deterministic ETL flows that you've created using Python, using whatever code you'd like, which are scheduled, rule-based, and stable. Or maybe there's also considerations where latency and cost dominate, meaning you have to kind of consider how many tokens are being used by these respective agents or what the cost ends up being. In our opinion, a crew really earns its keep when you're, again, dealing with all those respective sources and potential needed actions for one given workflow, where the enterprise needs of validation by a human and of an auditability of all across your reasoning chain ends up being important. And again, on an obvious end, situations where the workflow repeats, where every single day you have to create that morning desk note, et cetera, et cetera. Our general advice on this end is pretty simple, honestly. It's sort of start with the smallest thing that works, whether it be sort of a POI script, then go into an agent, then go into a crew. It's important to kind of on a only when needed basis, understanding kind of what technology to use depending on what the workflow demands. Now, key risks and how can we kind of mitigate them? So some of these risks we ended up actually kind of pulling up directly from a few of the major, I guess, technology standard places like NIST and even OWASP. And a few of the big ones are, the whole idea of bad data in, equating to bad analysis out, hallucinations, and even prompt injection. So having suspicious inputs, which end up actually having a prompt hidden them somewhere, allowing someone to do nefarious activity. So like the mitigation for some of these is a lot of the things we just discussed already. So having validation gates first to confirm schema and to look for and to quarantine data before any analysis comes in. Having those audit chains and having that reasoning chain sort of documented out on the back end to ensure that every sort of output you have is very clearly grounded and cited. And there's a human approval in the loop to kind of ensure, okay, I understand why this respective bullet within the morning desk note was present. Now, there's obviously access concerns, sort of unsafe tool actions and writebacks. That's also kind of something which the broader enterprise perspective of using least privilege access, of slowly sort of staging how much access a agent or a tool ends up having to your respective platform or technology infrastructure, that's where that ends up being key. On the prompt injection side of things, again, this is very clear across all the major industry standards bodies we've seen as a valuable issue. It's important to kind of go in and have screening for inputs. So obviously having the processes in place to where whatever input file that comes in comes from a trusted source, having sort of maybe QA checks in that sort of initial agent to say, hey, is there anything anomalous here? Is there any sort of body of text which shouldn't be here? It's important to kind of not necessarily trust every single input as sort of just being as is. It's important to kind of build out those controls to ensure that you validate that before moving forward with your agentic flow. And back to the original point on the sort of safe deployment framework. So this will, for those who were in our last few webinars, this will look quite familiar, but basically the way to kind of think of this is having a staged trust model, and trust is very key and trying to get, situations like this present and live within a large enterprise. So having an agent start read-only, slowly staging the number of tools that an agent in itself can particularly access, having validation and maybe more manual approval workflows before publishing, being able to log every single tool call and having humans in the loop in various points. It's important to kind of explore and experiment across each of these sections of the framework to allow you to kind of go in and just slowly ensure that when this thing is automated and this thing is live, you're in a situation where you can trust it. Another point we wanted to bring up was obviously the age-old point of model costs and cost of AI in general. Obviously, there's been a lot of hullabaloo regarding sort of token maxing, et cetera, et cetera. It is important to understand that having model routing can be a very valuable approach here. Perhaps parsing that already semi-structured piece of data doesn't necessarily need a Claude Fable. Maybe you can use sort of a process where you only pull or only call the least but good enough sort of model needed for every respective task. So finding efficiencies on that end are very valuable. Again, we try to build out this framework and build out those risks using NIST's own AI framework, where they kind of say it's important to govern, map, measure, and manage. And it's important to kind of treat AI as any other operational risk within your enterprise, not just something necessarily special. So obviously all relevant due diligence you would do with any business process should be present using AI as well. So what are our key takeaways here? Our key takeaways here are that multi-agent AI is controlled workflow automation. It's not necessarily more agents. It's not necessarily smarter agents. It's sort of having that flow set up and having that orchestration, that ability to orchestrate all of these parts of a workflow set up. These crews really pay off when those workflows need specialization, need those validation gates, and need those sort of audit trails, which is one of the big reasons why commodity desks are a pretty good fit for that. So again, having those validation gates, having that human approval really allows you to turn AI output into something that a desk can actually trust. On the North Gravity side, we're obviously working on our own capabilities on this end. Within our own data management platform, we've kind of built out those sort of plumbing tools like QA of a given workflow, like outlier detection, et cetera, to allow people to kind of make the inputs that come in AI ready and to allow people to kind of have the freedom to build those workflows. So we are very excited to kind of continue on that journey and build more and share more with you guys as we go through it. Either way, thank you very much for everyone's time and listening to this presentation. If you're interested in more of these cool AI use cases we've done with clients or the North Gravity platform as a whole, feel free to contact that email you see below. Thank you.
Thank you for that, Ani. We did have a few questions. We're only going to submit one because of due to time, but again, if we don't get to your question, feel free to email the info@northgravity.com and Ani can get back to you. So the question I'll put in there, I already struggle with data quality. Isn't AI just going to make it worse?
It's a good question. So the way that we would kind of frame this is those elements which kind of make your workflow responsible, having those validation gates, having a separate QA agent, et cetera, really makes it so that it's actually the opposite. It kind of allows you to secure whatever data goes through either of these automated workflows by design. Again, the crew, as we could see from that morning desk note, for example, has the ability to go in, hey, we have this market data, we have this. Oh no, this looks like we're missing data for the last day. You're able to validate that data before it analyzes anything, and that data ends up being quarantined at the gate. So again, in an irresponsible case, obviously, data can kind of flow through start from end if you end up using a single agent, as we were talking about earlier, as a potential risk. But in a situation where you're kind of able to create these gated workflows, we believe that if anything, the risk of that data going into creating a bad output ends up being a lot lowered.
Okay. All right. Thanks, Ani. As we're at time, we're going to end it there. If you have further questions or want to know more about North Gravity, info@northgravity.com, and keep an eye out as we continue our sharing our progress using AI within the North Gravity platform. We'll keep these sessions going. Thank you all. Have a good rest of your day.
Thank you, everyone.